So for testing for mean, we have some terminology. We also see some of them already in chapter 8, right? It's a similar pattern, but now you have a little bit more, which is the mu naught here and the hypothesis. So we have N is sample size, X bar sample mean, S sample standard deviation, mu population mean, and mu naught is the mean under the null hypothesis H naught. And for our case, we consider 3 different testing problems: mu equal mu naught versus mu different mu naught, mu equal mu naught versus mu greater than, which is the right tail, and mu equal mu naught versus mu less than, which is the left tail. And here are 3 of them. Okay. So in the case of unknown, which is most of the case, right? In reality, right? The population variance unknown. And if we test this problem, either the two-tail test, H naught mu equal mu naught, HA versus HA mu different mu naught, or say H naught mu equal mu naught versus HA mu greater than mu naught, which is the right tail, or either the left tail, right? H naught mu equal mu naught versus HA and mu less than mu naught. So if the requirement 2 star, as in chapter 8, right? So we have that in chapter 8. We'll put it here in the next slide, but they just follow the same. Okay. So testing and confidence interval, they just kind of 2 direction. Okay. They can be translated back and forth. And then the Z statistic T will be calculated by X bar subtract mu naught divided by S by square N. So you saw it already when we talked about Atlanta water quality index. I'll show you, and here the theorem is formulated here. Where X bar is sample mean, S sample standard deviation, and sample size, and mu naught the value under H naught. And addition, we can prove that T will follow T distribution with N minus degree freedom. And N here is your sample size, okay? So these are 3 theorem. And there is some requirement, just repeat what we see in chapter 8, right? Sample size, simple random sample size less than 5% of population size, and it's normally distributed, you have a large enough sample. So from that here, this theorem, it will give us, okay, so this theorem 9-1 here, it gives us the decision when you use critical value methods here. So when you use critical value methods, if you look at the right tail test, okay, and if your tested T here is greater than T 1 alpha n minus 1, so just the inverse T of at 1 alpha of n minus 1 degree freedom, and then you will reject A naught. For left tail test, the way you reject A naught is that T less than T alpha n minus 1. And for a two-tail test, it will be either T less than T alpha by 2, n minus 1, or T greater than T 1 alpha by 2, n minus 1. And all these values can be calculated by the inverse T function, right? Of n minus 1 degree freedom. And the value before that will be either, alpha, 1 alpha, alpha by 2, or 1 alpha by 2 here. It just depends on what the T cutoff you use it, right? So here, here, it just, again, it shows that, right? For right tail test, this is the rejection region where T greater than the cutoff. This for the left tail test cutoff region, and this for two tail, either less than this side or greater than this side. So we look at a Facebook visit example here, so we can see how this thing can be calculated, and we make decision, okay, in more detail. So a study in 2019 showed that the mean time spent to visit Facebook was 20.8 minutes, okay? And here, a social scientist, he suspects that the mean time has changed, okay? Changed, which means it's no longer 20.8, right? He didn't say that it's less than or more than, but he said it must change. So which means he said different, right? Collecting a simple random sample of 60 visits in 2023, the scientists found that the mean visit is 21.5, sample standard is 3 minutes. Conduct hypothesis testing for scientists at significant level alpha 0.01 using a critical value method. So there are 3 different methods, right? We can use it to test the problem, but now we look at the critical value method because we just learned how to do that, right? And here we talk about the mean, which is the mu. So the first thing is that we need to specify a testing problem. What he suggests here that the mean time change. So change compared to what, right? We need a benchmark and compared to 2019, which is 20.8. So the hypothesis he wants to set will be HA mu different 20.8, and which is the H naught will be mu equal 20.8. And this is a two-tailed test problem, two-tailed problem. And because you want to use the critical value method, right, to make a decision, and then basically like this is where you need to look at, right? First, you need to calculate the test statistic T, and then you look at the cutoff for the critical value method for the two tail, right? So depend on the left tail, we have different way to choose the cutoff, right tail different, and two tail here. So here the T will be x bar subtract mu naught divided by s square root n. X bar you get given to us 21.5 here. S is 3, n is 60, right? N is 60. So we have all that. And the mu naught is just the value under the null hypothesis, which is 20.8. So now you plug in and you can find the test statistic 1807. And then your T distribution will follow the 59-degree freedom, right? MS1. And then the cutoff will be T alpha by 2, MS1, T1 alpha by 2, N minus 1, right? So you need to calculate these two cutoff because your alpha is 0.01. You say here, right? Test at alpha 0.01. So this is a pre-specified value. Which that's in problem. Sometimes 0.05, sometimes 0.01, 0.03. It just depends on how stringent you want. The smaller alpha, the more stringent the test is, which means it's very hard. It makes it harder for you to reject the null. I suppose the hypothesis. So in this case, because your alpha 0.01, so T alpha by 2 will be just a 0.005, right? 59, n minus 1, 59, right? So which here, yeah, invert T here, just do invert T 0.005, 59, plug in and you get this value. And the same thing, you can also do invert T of 0.9995, 59. But again, the good news is that we have a symmetric here, right? I think that this is a T here, not a Z. Oh, we have a symmetric, right? T. Okay, T here. Bonus 2662. Okay. But you can also plug in invert T of 0.995, 59. You should see 2.662 here. And finally, when you get the two cut up, right, you need to compare. You need to check whether your T less than or T greater than. If it belongs to one of these two satisfy, and then you can reject or not. And if not, then you cannot reject, right? And here you can see that your tested is 0.807. It does not less than this value. It also does not greater than this value, right? But in fact, it's in the middle. So which means you cannot reject a no at significant level 0.01. So that will be your conclusion. So here you can see the first case, you see that you can complete the hypothesis testing problem using the critical, here you use the critical value method. So with the data you collected, you can support or reject a hypothesis or claim. And here we're using the critical value method. So now we look at the quiz and water quality index. So here, like again, the problem again, the researcher he thinks it's not drinkable, right? Which is the average water quality index is 69. And from a random sample of 6 water quality index collected in Atlanta, he found that the WQI value is 68, is 71, 70, 72, 73, and 69.8. Okay. So this is what he found from 6 samples here. And suppose that the data are normally distributed, okay, and using the critical value method to test the researcher claim at a significant level, alpha 0.05, alpha 0.01, and alpha 0.15. Okay, so we have different cases for the significant level here. So let us walk through this problem step by step. Okay. So first and first, again, you need to set up, right, the alternative, right? H1, HA, which is mu less than 69 here, versus the H naught here in this case, mu equals 69. And you're testing for mean, right? Mean mu. And this is a left tail test. Okay, left tail test. It's important to know whether you talk about left tail or right tail or two tail, because it depends on what test you're doing. The decision region will be different, right? So you have like 6 sample, right? Of 68, 71, 70, 72, 73, and 69.8, which is your data here. And you want to use the critical value method for left tail test. So basically, they look at the theorem here, right? So if the condition 2 star met, right, and then calculate test statistic T, and we will make decision reject the H naught if your T less than T alpha M-1, right? So the left tail test, this case. So you will need to calculate which is X bar subtract mu naught, right? So this case will be 69 divided by S square root of N. And you reject A naught, okay? If your T less than T alpha N minus 1, okay? So this case, your N will be 6, right? 6. And remember, you have 3 cases for alpha, right? We do one at a time, but I just noticed here, right? Alpha 0.05, alpha 0.01, and alpha 0.15, okay? So for our problem here, let's look at this using the TI here, right? So you need to calculate the mean and standard deviation. So first, we'll start here, edit here, plug in all the value. You have 68, 71, 70, 72, 73, 69.8, 68, 71, 73, 72, 73, 69.8. And start here. Count here. Yeah, 1. So the mean you got here is 7633. The S will be 1768, right? Use the S, okay? We don't use sigma here. 168 here. So what you got here for your mean, it will be 7633, right? Subtract 69 divided by S, which is 1768 by square root of 6. So this is your test statistic, okay? Seven six three three 633 subtract 69 divide by S, which is 1768 divided by square of N 6, right? So your test will be 262, right? 2.262. 2.262. Okay. So now see, you reject A naught if your test is less than that. So at the time, if your alpha is 0.05, your T 0.05, 5, right? In this case, M minus 1 will be 5. Will be equal invert T of 0.05, 5. And the same thing, in this case, will be 5 will be invert t 0.01, right? Right. In this case, it will be t 0.155 invert t 0.155, right? So now just plug in to see if you have any case your t less than those, right? And if it's less than, and then you can reject the H naught, right? So first thing first, invert t, second distribution here, invert t, the area is 0.05, degree freedom is 5, negative 201, negative 201, 015, right? 015. This guy is about, so which means in this case, you don't have that, right? Yeah, t does not less than t055. So basically in this case, you cannot reject, right? So for the A, yeah, you cannot reject not, right? At alpha 0.05, okay? How about let's do a 0.01. If it cannot reject 0.05, for sure it cannot reject 0.01. But I just make it here for completion, okay? Because 0.01 even a much smaller negative value here. The same, right? It's just a negative 3.365. Right? So again, you cannot reject here, right? Cannot. The same conclusion. How about 1.15 here? It's 15% significant level. It's pretty high, but let's see what we find. 1.15, negative 1.15. So again, so on three for here, right? For both all three cases, right? Negative 1.56, right? Negative 1.156, right? So you cannot, right? So the same conclusion for all significant level. But saying if I go very high, what if I choose alpha at 0.99? So that my t 0.1995 will be 3.365, right? 3.365. 3.365. So at the time, you can see that our t here is 2.265, right? 2.262, right? Our t will be 2.262. Will be less than this guy for sure. And basically, you can say you can reject, right? The H naught at the significant level 99%. But basically, this will be the something people won't buy, okay? Because you want to reject a thing with a significant level is low, okay? Alpha is low, not that high. And typically, the alpha 5%, 1%, 3%. If you want to be liberty a bit, it will be maybe 15 or 10% at most. But people won't buy that. Okay, won't buy if you want to go to that high. Okay, so you can see that like if you make the significant level high enough, and then you can always like reject your hypothesis at that kind of high significant level. But often in the terms of practical, it don't have the meaning, uh, practical meaning, right? Because there's no reason to go to this significant level that high, that high. So this is very important, when you say that, you reject the no, but at what significant level, okay? So people look at your conclusion in two chunks, right? Whether you reject your no, you can support your hypothesis or not, and at what level, right? At what level? And other time people, the smaller it is, basically like your data support your conclusion stronger, stronger. And here the method 2, we call it p-value method. So in this case, instead of calculate that statistic, right, and compare with the cutoff, we do something else, which you calculate the p-value. And again, it depends on, oh, by the way, I think like we did forgot to check the condition, right? So I think it's always a good practice to check the condition, right? And before we apply the theorem. So here, like you can see that in order to apply the theorem, we need to check the condition 2 star, right? I think, did we check it here? Oh, we forgot to. And so basically, like you need to look at it, right? The sample, random sample, so often is typically satisfied. The sample size less than 5%, but potential size of both the Facebook and the water quality index should be fine. The data are not more distributed, right? Population normal sample size large enough. So in this case, you get about 60 visits, so it's large enough, so don't have to care about the population distribution. In this case, you have about only six, right? Six observation, but it already told that data normally distributed, so all conditions satisfied, right? So it's always a good practice to check it too, okay, before you apply anything. And here, in this case, if condition 2 are met, and then we reject the A naught as box HA as significant for alpha if the p-value less than alpha, okay? And here, how you calculate the p-value. So for the relative test, your p-value will be equal to probability of t ms1 greater than or equal to t. Lateral test, calculate in different way, and two-tailed test in a different way, okay? And just basically, just how you do that. You just use TCF function for t ms1 greater than or equal to t, just TCF from t to a big number in m-1 degree freedom. And similarly, right, very small number for the left side, and two side, which is just 2 times of the TCF of absolute value, 999 ms1. So for the Facebook example, we revisit it, right? And we calculate and the TE1A07 here. And again, the T will follow T59. And because this is two-tailed test problem, right? So this is your p-value. P of t ms1 greater than or equal to t. So here like greater than or equal of 1A07. And again, here we do have this translation, right? Which is 2 of TCDF of this absolute to big number, ms1 here. So it will be 2 times TCF of 1A07, 99999, 59, and then you plug in your calculator, right? With TCDF, you should be able to get like 0.076. And this value, you can see that it's much bigger than 0.01 because this problem, the 921 here, you look at the 0.01 significant level, right? So you see that if your p-value less than alpha, then you can reject, right? You reject. But here, because this case, your p-value greater than alpha, right? Greater than alpha. So you cannot reject the hypothesis here. So let us look at this quiz here. The claim is that at 12 a.m. body temperature, the mean is less than mu, less than 98.6 F, right? Even n equal 3, you have, so basically you have a data from 3 people. Data normally distributed and the test statistic AT negative 2.855. Find the p-value. So that's a question, okay? And again, here, like in order to find the p-value correct and the process makes sense, right? You have to state the problem correctly. So first thing first, right? You have to state the problem correctly. So the testing here we care about is the testing for mean. And the hypothesis here, the claim here that mu less than 98.6, okay? So add one more slide here. So you want to test HA. Versus H naught, right? 98.6 here. And we testing for mu. Right. So in this case, we have this is a Left tail, that's right. The left tail. Less than, right? Less than left tail. So you need to calculate your p-value in this fashion. T n minus 1 less than or equal t, right? And here, remember your n here will be 3, right? So basically, you want to find the p-value by using t2 less than or equal than t, right? T. So there's a formula here for left tail test. T2 less than or equal t. And the t is calculated for you already, right? Negative 288, 258. Okay. That's it, right? N go 3. So how you find it, right? Just a TCF, a small number, 999. Put, okay. You can put more you want, but I think 999 here should be fine. In 2-degree freedom. So see what the TCF here give us. Distribution. Okay, they already give a very small number already, so we don't need to replace it. But you can replace for negative 99 as well if you want. But I just keep it like that. So I don't need to redo it, okay? So here, like, the reference with 2, right? So you got like 0.61. 0.61. So this is a p-value, okay? So what is the final decision if we test the claim a significant 0.04? So in this case, you can see that you can reject a not if the p-value less than alpha, right? So in the case, your alpha 0.04, right? And because the p-value is 0.04, so you cannot reject, right? Cannot reject. Is not at alpha 0.04. But here in this case, see here, you'll be a bit more liberty, right? So alpha increase to 0.2 here, which is in some cases, is still okay, is acceptable, right? But if for the case of alpha 0.2, right? In this case, you can see that your p-value is less than, right? So in this case, you reject the H naught at alpha equal to 0.2, okay? So again, you have to be very clear, okay, whether you reject or not and at what significant level. And for sure, significant level, we want to be at a small side, right? Small side, maybe 0.05, 0.1, or maybe at most 0.2. We don't want something like maybe 0.999, okay? Okay, the last method we learned here using the confidence interval method, which is, but it only apply for 2-tailed tests for our scheme, okay, for our level. So here in this case, you will construct the confidence interval like in chapter 8 we did, and then you will check whether it includes the value under H or not, right? So for our case here, you can construct confidence interval for the Facebook example, right? You will revisit and you can use TI calculator with a T interval function here, and this will be your interval here. And when you check an interval here, you see that the interval will include the value under the null hypothesis, which is 20.8. So which means you cannot reject the null at the single level 0.01. Okay. So basically, like it doesn't matter what method you use, it will give you the same conclusion, okay? Because they just interconnected. And different people, they have different, preference in choosing the method. And in reality, a lot of people, they prefer to use the p-value method because it does give some additional insight, especially it tells us like how extreme, to get such a data when the age not true, right? Which other method cannot offer such insight. And here the good news is with your TI calculator, you can find the test statistic very quickly. You can also find the p-value. So basically, if you use the p-value method and your TI calculator can give you the p-value, and what you need to do is that you just compare the p-value with the significant level to make decision. And if your p-value less than significant level, and you can say you can reject the A naught, right? And if not so, and you cannot reject A naught. And your TI also help you to obtain the tested value. Okay. And there are two tracks, right? Sometimes you are provided the start statistics, right? So for example, like the example Facebook, right? They give you descriptive statistics for 60 user in terms of mean and celebration. But sometimes you are only provided the raw data, like the Atlanta Water Quality Index here. So if you have a raw data, and then you need to input the raw data in a column for your one here, and then you process thing with this first track here. If you get the process data, and then you go with this track using the start here and insert. Okay. So let us go through the Facebook example together and see how we are going to use the TI to process this testing problem. Okay. So we have the mu naught is 20.8. The mean time from the data is 21.5. S is 3, right? S is 3 and N is 60. So let us plug in the process data together. So to start here, you go to test. And for our case, we do the t-test, right? The t-test. Sigma not, you do t-test here. So you go with the track because we have start here, right? The mu naught you care about 20.8. The mean under the no. The x bar 21.5. The S is 3. And the sample size 60, right? 60. And people care about different, right? Different change, right? Calculate, yeah. So here you can see that this is 1.807, right? Just consistent with what we saw before. The p-value is 0.076, right? 0.07. 0.8, right? And if you use the critical value method, and then this your calculator don't give you the cutoff, right? You need to find yourself. And again, it just I just use what we have before, right? T alpha by 2, just invert T alpha by 2 here, which is 0.005, 59, and give us this value, and this, right? And this value for sure, 1.807 here. You also see the TI, right? It's there not outside the range, right? So you cannot reject. So for the critical value method, you need to find the cutoff, okay? And then make decision. For the p-value method, our line will be similar, because what we need to do is that you just need to look at the p-value here, which is 0.0676 here, and compare with the critical value, the significant level they want, which in this case they want 0.01, okay, 0.01. So in this case, you can see that you just need the output here, and from here you see that you cannot reject, right? You cannot reject, right? So basically here you cannot reject. Reject, right? It's not right. Look at here, copy here, okay. Yeah. 0.01, right? Because the significant level bigger than the less than the p-value, right? P-value. Okay. And the same thing, for a counting interval method, which is, you use the interval, and I think we just have it before, right? And it does include the value under the mean, the node, so you can reject a naught. So basically, let's say, again, when you use the calculator, and we consider the testing for the mean when sigma unknown, right? Which is a more polar case in reality. And if you use the p-value, your life will be very simple because the computer, the calculator, it already give you a p-value. So all you need to do is just look at the significant level and see whether your p-value is less than or not. If it's less than, then you reject, right? If it does not, then you cannot reject. But say if you use a critical value method, and then other time you also need to find a critical value, right? In the p-value method, you don't need to do anything. Just look at this value and compare with significant level to make a decision. But for critical value method, you have a critical value method, which is what you get from the calculator will be the tested t, right? And then you need to find the cutoff to make decision.